I'm Jedi, and this is my first video for Demo 9. Um, Over here we have the ALU, the test circuit to be specific, and we're gonna try these 8 modes, or the original 4 modes that we had, plus the 4 extra that we made. To begin, let's start with mode 1. For mode 1, or let me get back to mode 0, it's supposed to be subtracting A minus B, so let's do 4 minus 1, and as you can see, we get the result right over here in 2 different ways, in binary and hexadecimal. And let's try, that's 12 minus 5, we're gonna get 7. Now, mode number 1 is add A and B. So, if we add, for example, 9 plus 1, we get 10. Then hexadecimal, it's A. Let's try, for example, adding 5 and 3, and we will get 8 in both ways. Let's try multiplication. Okay, so now, trying multiplication, we have 5 times, let's try 5 times, or let's try, that's 7, we'll do 3 times 3. As you can see here we have 9. Let's try multiplying the most significant bit right here for mode number 3. We're gonna need bigger numbers here because, you know, these are least bits. So let's try, for example, 8 and let's try 4. Yeah. So multiplying 8 by 4 would give us 32. We have a 2 here, but that is because multiplying in binary, we will get 0, 1, 0, 0, or 0, 0, 1, 0, 0, 0, 0, 0. And this is the most significant bit in that order. Now let's try mode number 4. We have 8 divided by 2, divided by 4, and we get 2. Let's try a different number. We'll get 12 divided by 4, we'll get 3. And 12 divided by 6 will get us 2. Now for mode number 5, we're negating A using 2's complement. So let's try and put A this way. And for the second mode, as you can see, so 2's complement, it just negates the inputs and then adds 1. So it's supposed to be 1, 1, 0, 0 after 1's complement, 1, 1, 1, 1, 1, 0, 0, and then adding 1 will give us 1, 1, 0, 1. As you can see here, no matter how much I change B, it doesn't really affect it because the input here is just for A. We're trying to negate just the inputs of A. Now for individual bit comparator, this will only turn on if both bits have a 1. So, as you can see here, if both, or let's try it this way. We have A equals 11 right here, or 1, 0, 1, 1, and B equals 8, or 1, 0, 0, 0. This will only show 1 here, but if we try and match another bit with of B with A, it will also show here, and will show the value translating into it in hexadecimal here. For the final mode, or mode number 7, it's A or B. Basically, what this does is it will only give the inputs or the set of bits that are different from each other. So say we have this set right here. We have A equals 0, 1, 0, 0 and B equals 0, 0, 0, 1. The first bit and the second bit are different from each other, and here it equals 1 and here it equals 0, or here it equals 1 as well. So as you can see here, it will show. And the same is true if we put it as 1, or if we put it all as 1. The only bit that will show is if they're different than each other, as you can see. Now let's see the circuit, or the internal circuit, and how did we come up with. So as you can see here, we have the A input and the B input with the first three or the first four functions that were connected to it before. So basically I decided to add to it what is easily addable. For example, from the functions there was an adder, or sorry, a divider. So basically I just added that and connected it. I made a negator function that will turn the inputs into, or negate the inputs of A using 2's complement. And as you can see here, it only has one input spot, which is A, which is for A. I also have the individual bit. I also made the individual bit comparator and the A or B circuit, and basically just connected that all together, and then use multiplexers similar to how we used it here, and added one select bit to basically add more bits so we can use 8 modes instead of 4. This circuit would be useful to use in a calculator. As you can see, it has many different functions, counting negation, individual bit comparator, dividing, multiplying, and the normal calculating functions right here. That was my first video for Demo 9. Thank you for watching, and goodbye.